You mean you would train the AI once on how you could ascertain whether someone needs to be hospitalized for a certain set of symptoms, and then it would look for patterns in a whole bunch of data where people were or were not hospitalized and what happened, and then you'd have your AI, at least in that part, that would help the doctor, right, the physician.
Yeah, and what's key about this is that that example, let's say I did train a model that could look at a note and decide whether someone should be hospitalized at the same performance level as a human expert, a physician, let's say. When I train that model with that data and that objective, it can do that one thing. It's not going to be able to then write me a poem, right, or help me on my taxes or give me,
Or do surgery, or even within medicine. Yeah.
right. So that's what we would call narrow AI. What we are talking about today, generally when we refer to AI, is now generative AI, which is not narrow AI. And the reason there's a big difference is that example we just walked through, I specified the input and the desired output for a given task. With generative AI, I'm not prescribing any particular narrow task. I am, in this case, as I was saying, with these self-supervised training approaches, I'm literally just taking all of the text on the internet, let's just say digitized text, and I'm just predicting the words in the text, self-supervised. So I'm not telling it, I want you to do exactly this task. I'm literally just saying, learn this text of let's just say all human knowledge. What's interesting about that is if it's really good, it doesn't matter the domain. So now if I give it that same note that I did in that narrow example, and I say, should this patient be hospitalized or not, there's a chance that the model actually will have a pretty decent performance because it's learned patterns that conform to things that we think about in the world and the way that we communicate and all those things you have to know. So it's fascinating. And that goes back to the idea of emergent behaviors. There's just some things that these self-supervised models are able to do that we all enjoy now today that no one trained them specifically to do, but yet because they learned all of the sort of words and how they work together and how language works and the concepts behind that, we can use them for a lot of useful things.
So through language instead of language, can have papers in it. So you can see the results of direct experimentation. You can see opinions from professionals. You can see, studies. I mean, you can see clinical outcomes. You can see all that, I guess, and you have access to it all and look for patterns. So you're backing into a result using, I guess, language or what's been written by countless people.
That's right. That's a really great way to say you're backing into it is a great way to think about it. You're not going in with a specific directive for this task A. You're actually backing into it by saying, just learn all the concepts that we have ever written down, right? And then stitch those together in this massive model.
Okay. So what specific applications have you worked on in the past, or, are you working on now that you can talk about, and how did AI help you to figure out, how to get a better result?
Yeah. I mean, when I started my career in sort of AI in healthcare, we focused on a very common type of medical imaging examination, the chest x-ray, and 2 billion are done every year. And we said to ourselves, if there's a way to learn the patterns of dogs and cats and all the great things that were going on with ImageNet, we could probably learn some of the same concepts in a medical imaging exam. So that was actually one of the first things that we did. We were one of the first to describe that AI models actually could learn pneumonia and cardiomegaly and other problems that you can find on chest x-rays. Now over the years we've translated a lot of that. It led to tons of real applications that are now in practice, et cetera. But what we are now doing in generative AI is a bit different. Here we're saying we can actually take complex text-based workflows and automate them into some extent from the same model. So for example, you may have heard of the ambient note solution where you can have a conversation with your doctor and the note gets automatically generated for your doctor. So it saves them a ton of time.
Well, so he doesn't have to sit there typing into the computer. It says a listening, transcribing, or not even transcribing, but listening and speech to text, and then no produce.
Yeah, 100%. Right. So think about how hard that problem would be if we went back to those narrow AI days. I'd have to say, I have this transcript in our conversation, right? If you're seeing me as your doctor, we might talk about the weather. We might talk about your cousin's wedding in addition to your knee pain. Now, you have to be able to have the, contextual awareness to look at that transcript and only take out the things that are relevant for the note that I'm about to write. That's a hard problem for those narrow days, because think of all the different if-then statements I'd have to think through. If they mention their cousin's wedding, that would be an infinite, things to think about, right? So to make a narrow model to do that. But now, because the model can generalize and think about, okay, well, they're in the context of seeing their doctor. The things that the doctor needs to put in a note are, things related to their knee pain, right?